and share my screen. All right, welcome everybody. We are thrilled to have you here at Boosting Your Chatbot's Intelligence with Retrieval. I am Amanda Wagner. I'm the Senior Community Manager here at Pinecone. And for those of you who are not familiar with Pinecone, though I suspect many of you are, Pinecone is a vector database that makes it easy to build high-performance vector search applications. Now, before we get into today's content, we have a few housekeeping rules that are very important. Number one, we ask that you use the chat for chat. Feel free to say hi, let us know where you're coming from, let us know how you're using Pinecone. But when a question arises, we ask that you place that question in the Q&A portion of the chat, of the Zoom, and not the chat. There's a lot of folks on today. I'm sure there's going to be incredible questions, and we're going to answer as many as possible within the allotted time. So that makes it a little easier for us when you add those to the Q&A portion. If you've missed something, no worries. This event is being recorded, and we will share it with you after the event. We also post all of our recordings on our YouTube channel and social media. So if you want to take a look at past events, I highly suggest you subscribe and follow today. Along with that post-event email, we include a survey. It takes about 30 seconds. Let us know how we're doing. Let us know if there's something you would like to see from us. All of your feedback is treasured. If you have a question after the event or want to collaborate on an event, you can email me personally at amanda@pinecone.io. Now, without further ado, I'm going to turn it over to our developer advocate, James Briggs, to take it away. Take it away, James.
Thanks, Amanda. So, actually, 1 second, I will share my screen quickly. Okay. Lost the window. Here we go. Okay, almost done. Okay, cool. So, let's jump straight into it. Right, so yeah, so I just wanted to, we're going to start by just introducing kind of the space of NLP. For those of you that are kind of new to that, like I'm sure for a lot of you, you've probably seen this sort of thing before. For those of you that are new to it, I think this is a pretty good context or background. That's what we're going to be talking about a little bit later on in the presentation, which is more on the sort of chatbots and conversational AI. But let's start at the start, give that context. So, like a while back in NLP, it was very difficult to kind of get started with even like a simple use case. Not even that long ago. We're talking like 4, maybe 5 years ago, and maybe a little bit longer. Basically, you would have to have these very specific, like specialized models for different tasks. So classification, you're gonna use a specific classify model that you train on some of the data. Question answering, you're going to use a specific question answering model that you've trained on some of the data. And even just within question answering, you have a ton of different types of question answering. You would have different models for each one of those. You already had like a ton of different models and approaches to doing all these different tasks. You'd have to retrain the model with different data sets, so on and so on. Then we had Transformers come along. They made things a lot easier. essentially you train a big transform model on a ton of data, and that would kind of become like your core model for a ton of different tasks. So with that, one very well-known transform model was the BERT transform model. So you take BERT and you'd be able to add a few layers onto the end of it, fine-tune that with much less data, and get much better results. So you would be able to do that for question answering or classification and a named entity recognition, tons of other things. And then from that time, from that sort of initial transformer time, transformers have progressed a lot, and they are now what we would call large language models. They're essentially kind of transformed, but just a lot bigger. And what we find like today, so whereas before, way back, we had to use completely different models for these things, then we had to use different parts of models for these things. Now, the only thing we actually change is the prompt that goes into the model. All right. So if you want to do classification, you just say, hey, can you do some classification for me? You literally write that. For question answering, you say, hey, can you answer this question for me? Right? Or you actually need to change the prompt. And obviously that's incredibly powerful, right? It's almost like you're talking to a person. You're just asking them to do something slightly different. Much easier than what we had to do just a few years ago. And NLP tomorrow, or also today, where is it going? So we see these large language models, we're going more towards the conversational side of things. So not only do we just interact with the large language model with like one question, but we actually kind of have a conversation and we kind of go through that interaction. We can fine tune our responses. We can ask the large language model to do something slightly different and so on. It allows for a much more natural interface to interacting with these models. One thing that the model can use tools, right? So, I mean, we'll talk about it a little bit more later on, but these models, they're really good at a ton of things and also really bad at a ton of things. And the things that they're really bad at, we can use tools in order to make that less of a liability. So we just tell the large language model, don't try and calculate this with your language logic. Actually, just use a calculator function instead, and some code will calculate it for you. And then also the ability to reason. So one good example of this is what we call chain of thought. So you can think of chain of thought as rather than the model just trying to answer a question immediately, it will actually go through a process. It will go through step by step to try and answer your question. And that's quite good because you can also integrate that with tools. So in that step-by-step process, the model can go through a few steps, figure something out, decide to use a tool, use that information, go through a few more steps, and so on and so on. So it's really powerful. And yeah, as I kind of just mentioned, tomorrow is pretty much already here in LangChain conversational agents, which is what we are going to be talking about today. So LangChain, I'm sure most of you know what LangChain is. It's already a big part of the surge in popularity of AI ever since ChatGPT came along. AI had just or the AI field is just week after week, there's something new and it's something big that is new. Like the rate of progress is kind of crazy. And in fact, look kind of like this graph, it's just like an exponential increase in the sort of abilities that these models are able to do. Right. And yeah, LangChain is hugely popular, as you can see here. It's one of the fastest growing repos on GitHub. It's huge and rightfully so. It's incredibly useful. So let's just talk a little bit about what LangChain is for those of you that are kind of new to it. So LangChain is the framework that's built around these large language models, right? So you think of the large language model as the core of this technology. They're like the kind of central processing unit of the whole AI world. And using this framework, we can take these large language models and we can use them to either enhance their ability as chat models if they are already chat models, or even for those that are not initially intended as chat models, we can make them chat models. We can do generative question answering, and we can ground that with real world knowledge or data knowledge, something we'll definitely talk about a little bit later on. We can use summarization over many documents, so we can kind of just process a ton of things, summarize them again until we can fit them into what is actually a limited context window of these large language models. And then we can also go back. We can also use agents. Okay, so that's something we're going to be talking about. You know, it's that full usage, that ability to reason, ability to do that on a conversation setting. So the design philosophy with LangChain is to have all these components, them to be modular, so we just kind of like put them all together like Lego blocks, and we use what's called chains to kind of link those all together. So a few of those, like kind of super quick intro to some of the key blocks or components in LangChain. We have prompt template, so you can kind of imagine this is like it's a template for your prompt. Okay, so you can say we want to put this here, we want to put this here, we want to put this here, and then that's quite good because then you can programmatically build your prompts, and this naturally actually powers a lot of the LangChain functionality, because you know we have all these modular components, we want them to all fit together well. That means the prompts need to fit together well as well, which is super important because prompts are like, they are kind of one of the most important parts of this like new age of language models. A good prompt will make like a whole world of difference in the performance of these things. So that's important. Another thing is the chain. So as I mentioned before, chains they're kind of like the core of LangChain, hence its name, and they are essentially a chain or a linked list of these different components, right? So like a very simple one of these is called the LLM chain. The LLM chain, it takes like a prompt template and a large language model and just put those together. So you put in some input, it gets processed into your prompt template, then it goes onto your large language model. Okay, relatively simple, but there are far more interesting chains that LangChain offers, far more complex and do a ton of really interesting things, and it's abstracted, so we don't really need to worry too much about how all of it is implemented, which of course is super useful. We have memory. So memory is super important, obviously. So there are many, like you can see here, we have this with conversational memory on the left, and we're simply just kind of remembering. And when we say remembering, it means basically feeding that into a new core to our large language model. We're remembering those previous interactions. But it's not always that simple. There are many different ways of creating memory. You can summarize memory. You can use a knowledge graph to remember different relationships in your conversation, in your previous interactions. You can, I think it's being implemented now, or it's recently been implemented. You can even use text search for these things. So looking through your memories using semantics. So that is also a very interesting feature in LangChain. And then of course, there's agents, which is kind of, well, a big part of what we're going to talk about today. So agents are the ability for a large language model to use other tools. So, like you can see here, like you can refer to a SQL database, you can run Python code. You can say, okay, can you run this calculation for me? The large language model is going to write some Python code. He's going to execute it and return you an answer, which is pretty incredible. And also, like just searching on the web, like that's a big thing. Because the large language model, it doesn't have any knowledge of the world beyond when it was trained. So having it have up-to-date information is super important. And again, that's something we're going to talk about. So in short, LangChain is pretty relevant. And if you're working with large language models, it's definitely worth looking into. So, on, okay, 1 second, sorry. Okay, cool. So, I mean, what can we do with LangChain? So this is kind of focusing on what we are going to be talking about in the context of conversational agents. You can kind of think of those as, or these conversational agents as being easily built and also custom ChatGPT-like agents that can be designed for use case specific. So imagine ChatGPT, but you can modify it in ways or give it access to particular data or make it say things in a certain way that fit with your use case. Okay, so that means a ton of things actually. So we can include custom tools there. So knowledge base, which is something we're going to talk about. Or also tools like we saw before, like the Python integration, the Google search, so on. We can give it a custom personality, we can give it a tone, give it an objective for every conversation, and we can also modify the memory. So obviously I don't know what ChatGPT does, but they will have a particular way of remembering previous interactions, and maybe that's not always optimal for your use case. So we can use all these other types of memory as well. So yeah, I mean that's a sort of a quick introduction to large language models and LangChain, and a little bit on conversational agent here. But what we'll do now is I'll pass over to Francisco, and Francisco will go into a lot more detail on all of this. So I'll hand over to you, Francisco.
Thanks, James. Can you let me know if you see me and you hear me well?
Yeah, all good.
Awesome. So very small introduction. I am an NLP developer. I have worked with machine learning as a developer for a few years. And I have made a few projects with LangChain. I have contributed to LangChain as well. And I agree with James that this is one of the most important tools, if not the most important tools, to actually build custom applications with LLMs. So I think it's really worth spending some time to understand it in depth. So as James was saying, one of the key aspects of agents is the fact we can use external tools, and we can enhance these agents with tools that help them when their general knowledge is not enough. Like James was saying, when you train an LLM, right, like ChatGPT or the models that are behind ChatGPT, these models, they have a general knowledge about what was mainly like common data from before 2021, I think is the cutoff date, or some new models have later cutoff dates, but they don't have specific data. And when we need specific knowledge, we need to give it provided with tools or with knowledge for them to be able to answer queries that are more specific. Next slide, please. So one example of this is math. LLMs are not good at math, at least not good at complex math. They might be able to answer you simple math questions, but when you start using exponentials like this, they fail. So one thing one can do is tell the LLM to be knowledgeable about its limitations and say that when it doesn't know how to solve a math question, or rather, don't even try to solve a math question that is complex, and instead use a tool. And we will tell the LLM how to interface with the tool so that it can do math by using a math tool, right? This is one example. Another example of when we would want to enhance LLMs with external knowledge, or with external tools rather, is when we want to add external knowledge. Sometimes we want our agent to be able to answer questions that are very specific to a specific knowledge base, right? To a specific topic. And if that topic is very specific, the agent will not have the knowledge in its weights to be able to answer the questions correctly. Here is an example. So if we ask about LangChain without any external tools, the answer will be wrong because it doesn't know the details about LangChain. Maybe it hasn't never seen any data on the LangChain library. So we need to give it appropriate information so that it will be able to answer questions like this in an accurate fashion. Next slide, please. So this is tools. So basically, we want to give the LLMs or our agents, we want to give them access to tools that help them answer queries better. And also, we want them to be able to reason on when they need to use a tool, and then incorporate the output of the tool to give us a final answer. So they need to be aware of the tools they have. They need to be able to use them when they are needed. And then they need to be able to answer using the combination of the outputs of all the tools the agent used. So we will ask the LLM to solve whatever problem we are giving step by step, right? And this allows us to integrate the tool usage. So basically, in some primordial sense, to reason, right? Next slide, please. So here is an example. If we ask, can you tell me about large language models? It understands that it needs to search to get an appropriate answer for this. So it uses a search tool here, and it gets the answer from the tool. And then it returns as a final answer using the observation it got from the tool. So this is how the reason, the React framework, which allows it to reason, combines with using external tools by thinking about which tool needs to be used, and then getting that input from the tool and returning. So basically, what we have in LangChain is the possibility of building agents that can handle conversations. As James said, they have memory, so they understand what has been said in the conversation and can refer to previous interactions. They can use external tools as the ones we showed right now in the examples, and they can reason with this framework in which they think. They decide if they need to use a tool. If they use it, they get an observation from that tool, and they integrate all the observations into a final answer. So this is React agents. Next slide, please. So now we will show you a demo after we finish the presentation, which will show how we can build a conversational React agent by using a vector database retrieval tool that basically, in the same sense that we would have liked to have LangChain specific information in the previous example I showed. In this another example, we will have specific information being brought to the LLM to be able to answer the questions correctly. This is the tool we will be using in the example. So a bit more about vector databases. Next slide, please. So maybe some of you have heard about vector databases. This is something that is really, really useful and has been around for a while now. But basically, it means searching for content, not by keywords, but by meaning. So the traditional way of searching, when we are searching something using Control F in a web page, for example, or in a document, we just type the word we're looking for, and the document is searched for that word. But this is a problem because sometimes the same word can have different meanings, right? So here are a few examples where the same word has different meanings. But for example, in the second case, very different words have the same meaning. So searching by words might sometimes get us results that are not optimal, because we will be getting either results of that have the same word but do not mean the same, or that have different words, and we will not be getting that result just because the words are different. So semantic search and vector databases allows us to get the results that actually mean the same things that what we're looking for, regardless of how they are written. Next slide, please. This is an example here. So this is the idea of semantic search brought to this use case of having an LLM getting information from a vector database and then using that information to answer a question. So if we would be asking where is Normandy, and the LLM knows that it needs to use a tool to find out about Normandy, it will use that question to look for contexts that have kind of the same meaning as the query. And when it retrieves those contexts, it will have, for example, here, Normandy is a region in the north of France, available to be able to answer the question to the user. So it will have this context that it didn't have before, and which will help it be accurate in the response. Next slide, please. So in summary here, what we're doing is when we have an LLM and we do not use any knowledge, any external knowledge with that LLM, it will only answer based on its internal weights that depends on the data it was trained on. And those responses are going to be quite general and not very specific when we're talking about a very specific topic, especially if that knowledge is something that probably the data that it was trained on did not contain, right? So when we want to give it access to other knowledge that is not from the training set, we will have to enhance it with external tools. Next slide, please. And in this way, we will be able to give access to the LLM to the external world of information. If we use a tool, for example, for searching the internet, it has access to the internet. But in this case, we're talking about vector databases. So it's not the whole world of information that we can find in the internet, but instead it's a subset of the world that we care about and we want our agent to be really knowledgeable on, right? Next slide, please. So we'll get a little bit more technical here. So how does this work? We first get all our documents. We embed our documents with some chunking that we decide, right? So we split our documents into some sentences or paragraphs, and we embed, we upload, we insert all this the meaning of each of these chunks into a vector database. And then when we are getting, when the user is asking a question to the LLM, what the LLM will do is to embed that question and then check in the vector database which paragraphs or which subsets of sentences have the same meaning, and will give those paragraphs or sentences to the LLM as context to answer the final question. So this is how it works. It searches the query in the vector database, gets the relevant pieces of context, and those pieces of context are provided to the LLM in inference time to be able to answer the question accurately. Next slide, please. Okay, so now I will show you a small demo about how this works. Let's see. All right, so you should be seeing my screen. If there's any problem, please let me know. I'll assume everyone is seeing the screen correctly. So one part we will not spend a lot of time here is in how we upload the information to the vector database. That is already done. So we can focus on the actual agent and the tool, right? What we have been talking about right now. But a small brief description of what we will be doing here. This is a data set of Lex Fridman podcasts. So the transcripts from Lex Fridman podcasts have been abstracted to a vector database that which we have. And this is how that was done, right? If we need to split them into chunks and send them to the vector database. We are splitting them using a utility from LangChain called the recursive character text splitter, which basically tries to split with different characters in a sequential manner trying to get to a specific chunk size. So it tries to split with 2 spaces. If the chunk is too large, then it tries to split with this separator. If the chunk size is still over 300, it tries to split with the next one and with the next one until it gets to a chunk size that is sufficiently small, right? So this is how we split our texts, and we are asserting them to our vector database. This has already been done, and now we have a database where we have lots of small parts of different podcast episodes of the Lex Fridman podcast, right? So if we want to use this in an LLM, we will first need to initialize here our vector store, which is another class from LangChain, and we will be using Pinecone. So this is our vector store with our index, which is the one where we asserted all our information. And we will have to initialize here our LLM. Our LLM is what James has been explaining, is this large language model, which we here are specifying the name, the base model we're using. And it will be the model responsible for handling all the conversational aspect of this demo, right? Then we need to initialize our tool, which is a retrieval question answering. So basically, you can ask questions and it retrieves different contexts to give us an answer. And it takes an LLM, and it takes the vector database that we created. So basically, this will be the utility that will be responsible for finding answers within the vector database when the user asks a query. A small detail here is that we are using chain type stuff. You can also use MapReduce. Basically, MapReduce will be summarizing the documents before returning or before inserting them as context. And the stuff option just returns the retrieved documents as if. So just for simplicity's sake, here we are using the chain type equal to stuff. So one very interesting part here is that we need to describe the tool to the large language model. So why do we need to describe the tool and how do we describe it? Well, our interface with large language models is always text. This is the fun part. So the way we describe a tool is basically as we would to a colleague. We just tell it what the tool is useful for. So here we're saying, use this tool to answer questions using Lex Fridman podcasts. If the user states, ask Lex, use this tool to get the answer, right? So we're telling it when exactly it should be using all this knowledge we have stored in a vector database. So here we will initialize our tool, where we need to specify 3 things: the name of the tool, the description, so our agent knows when to use it, and the function that needs to be run when we want to use that tool. This is the common interface we have with tools, and this is the same applies for example, the math tool that I explained before. It's the same thing. We describe when that tool needs to be used. We send a function or a method of what exactly that tool does, right? So this is what's going to be run when the tool is being used, and the name of the tool. So that's very generic. And we will define a memory. This is one of the memories in LangChain. There are several. Explaining all these memories exceeds the scope of this webinar, but this is a very simple memory that gives the LLM all the previous interactions as context when it's answering a new question. It cuts off at 5, so if we have more than 5 interactions, the latest ones will be forgotten. So here we specify which agent we want. This agent is the one we explained just before in the presentation, the React agent that is conversational. So it will be thinking about how to use each tool and deciding whether to return the output to the user based on the observations from the tools. Here we have only one tool, which is the retriever. So let's see. So we will initialize here our agent. And right, so here's a small description of why it's called Chat Conversational React Description Agent. That's a long name. So Chat Conversational means that it is able to maintain a conversation and to keep a recollection of previous interactions. React means this React framework, reason and action. We talked about this before. And description means that it will be relying on the tool description to decide whether to use the tool or not to use it. So we will stop just a short while in the prompt to understand what's going on. So the system message is the first part that we will investigate. The system message basically tells the LLM what it needs to do. So basically, you are a helpful chatbot that answers the user's questions. This is the first part of the prompt. Here it's quite messy, but maybe you can see it around there, around here. The second part of the prompt is called the message placeholder, which we will be able to see here. So here's the system message, here is the message placeholder. And the message placeholder basically will be holding all the previous messages that have been sent in the conversation. Right now, we don't have any, so we don't see anything there. And finally, we have the human message prompt template. And this is where all the instructions will be sent. So if we print this, we will be able to understand exactly what we're saying to the chatbot before the chatbot gets the input from the user. So it's quite interesting to understand here what's going on. So we are first sending the tool. Remember, we have the description. So we're sending the name and the description, so it knows when to use it. This is a small description of what tools are. And then this is all a context that we give to the agent to be able to reason in the way that React agents should reason, right? This is all to guarantee that reasoning capability. And finally, after telling the agent which tools it has, how to respond, we just send the agent our input or our user's query, right? So that's it. We just told our agent in a prompt what it needs to do, which tools it has available, and now it will get its input from the user. So let's see how this works. Let's begin our conversation. So if we say, let's stop for a second here. If we say, hi, how are you? We shouldn't expect the agent to use the tool. This is important because the agents must have this reasoning ability to discern when the tool is useful to give a better response and when it's not. So if we are not telling the agent, ask Lex, as we said in the tool description, we don't want it to use the tool, right? So we will see here that it will not use the tool because we have specified to the agent not to use that tool when it doesn't have that type of prompt. So let's see. Right. So this is the answer. Okay, we're starting the conversation. So there's here this agent executor thing, which we can briefly go over, which we can see here, entering new agent executor chain. And this agent executor basically is deciding whether it needs to use a tool or not. So it's where the React, the reasoning happens, right? Here it decided, the action was give a final answer. So it could have decided to use a tool, but it didn't. It decided to give a final answer directly. So this is what the agent executor does here. But if we say ask Lex, now we do expect it to use the tool, and we will see here we have a glimpse of what it's thinking about. We will see how it actually refers to the tool to correctly answer the query. So let's see. It's entering the agent executor chain, and now the action is not final answer. It's Lex Fridman DB. And what is the action input? Because all tools need an action input. It's what are Lex Fridman's thoughts on the future of AI? So what's going on here is what I showed in the last slides. It's getting the query, sending it to the vector database, finding the relevant contexts, and answering based on those relevant contexts. So this is the relevant context it obtained. Lex Friedman has posted a podcast called Artificial Intelligence. And right, so it's a lot of information on what Lex Friedman thinks about the future of AI. And now the final answer. So Lex believes that AI has the potential to transform our world for the better, but also recognizes existential risks. This would have been impossible if we didn't have the vector database, because it's very specific. We're getting context from specific podcasts and giving that as input to the LLM to make a final answer. So this information is really, really specific to the point of what we are asking. And just one more thing to show how the memory works. So these agents understand previous interactions and how these relate with each other. So if we just said, ask Lex about the future of AI, and now we say, what does he think about space exploration? It's clear that we are talking about what does Lex think, right? Because by context, if we have access to the previous query, we can know that we are referring to the previous interaction. So if we ask this, we would expect again to access the tool, to send a query, this time on space exploration, a different topic, and here it's getting the response from the tool, which is that the context, the information retrieved is not clear what Lex Friedman's thoughts on space exploration are. So basically, based on the conversation, right, it's citing the conversation. It seems that Lex Friedman thinks space exploration is one of the most inspiring things humans can do, both in the space of science and ideas, as well in the physical exploration of space. So it's actually quoting where it's getting that information from. And it's giving a lot of information, right? So he believes it has the potential to inspire a generation of new scientists. It's very, very specific. And I think this is the key behind what makes retrieval enhanced chatbots special, is that we can base our chatbot's knowledge on very specific data that we think is relevant for our use case. So with that said, I think we have enough time talking, and it would be nice to hear some questions.
Thank you so much. Can you hear me all right?
I can, yes.
We've got a lot of questions. Thank you guys for your input. Let's just get right in. I'll be jumping around a bit. So what front end stack do you guys recommend that has a low learning curve for interfacing the LLM/LangChain backend?
So that is, can you hear me okay?
Yes.
Okay.
James has been working on sound, everybody.
So
We're trying.
an interface for interacting with, like, between OpenAI and LangChain. Is that correct?
Yes.
Yes.
And LangChain backend. Yeah.
I can't hear you, Amanda.
I think the question was.
I can't hear anyone.
I'm going to send this to you.
Okay.
Well, you can't hear me, but
Give me a moment.
So I can answer from my side. I have not done much front-end stuff, so I wouldn't be able to give an authoritative answer to this. I've used Streamlit for other types of projects, and it's really easy to use. It's Python-based. I think it could be used. There's a specific Streamlit library called Streamlit Chat or Chat Streamlit, something like that. I think that would be an option, but I haven't tried many options to be able to compare.
thank you. James, can you hear us yet?
I can hear you, yeah.
Yay. Next question.
One thing.
Oh, yeah, go
One
for
thing
it.
I would say, which is quite interesting for this new paradigm, is that you don't need a very a very powerful instance to try out these things in a front end, because it's all API based. So there's very little that is actually running in the instance where you're running your application. So to do small demos or small projects, I think that lowers the bar of what you need to be able to put something out there and play with it.
Great, thank you. Steve wants to know, first of all, he says, very nice demo program / applications. What applications can we build with LangChain that can solve real world problems and provide business values? So maybe some examples of stuff you've seen.
So I think for anything that is chat assistance for users, especially if you want to provide access to users to a specific knowledge base. One example is code documentation in a more friendly way. And anyone can chat right now. So that is really democratic in a sense. So that is one application I've been seeing a lot that works really well. So basically giving access to information that you want your users to be able to access very easily. Another big area I'm seeing is using natural language to interact with large databases like SQL or even CSVs or JSONs, but mainly SQL. This is a topic which is a big issue in many companies, that non-technical people find it hard to get the information they need from databases because they don't really know a lot about SQL, and they need assistance from technical people. And if you can build, this is something that is being worked on, an interface where you just chat with your data, and I'm talking not about here documents, but tabular tables and databases. This improves a lot the access and the immediacy with which people can access key insights from the business operations.
Great. James, do you want to add anything there?
So I missed the question thanks to my headset. I mean, if you can repeat it, I can try and chip in.
Yeah. So what applications can we build with LangChain that can solve real world problems and provide business values?
I mean, yeah, I think kind of what Francisco said, like there's a ton of these like chat your data things where you're literally speaking with your data. I think that's probably the biggest one at the moment. Retrieval of information. So that's something that we've done for a while. So like the sort of semantic search where you're searching for documents. Like imagine like you're a big enterprise has documents everywhere. And generally speaking, it's a nightmare to find that information. So something that we thought a lot of before the chat models was just searching for those semantically and retrieving that information. Now we can like do the next level up where you're literally like chatting with that data, like having interaction, retrieving that information, and asking it to perform analysis over those documents. You know, the sort of things you can do is pretty wide ranging, and I don't think there's like a necessarily like a single thing you can do, but I think that chat with data is a really good starting point for a lot of companies.
Great, thank you. A few questions kind of getting into the nitty-gritty of LangChain. What is the need for blockchain in LangChain? How is it possibly storing everything with permanence of data?
I don't think there's blockchain. So there was a slide earlier where we asked, I think we asked GPT-4 what LangChain was, and it said and it said that it was a blockchain technology. It's not a blockchain technology. That was like a mistake. That's a hallucination from GPT-4. But that's a great example of where like you actually do need these conversational agents, right? Because you read that and you thought it was true. Because it's super convincing the way that it actually said that. That's why you need these sort of things. That's why you need a conversational agent, why you need like a retrieval component to actually retrieve that information, sort that information, so that you don't fall for the hallucinations of any of these models.
I love a good hallucination. What's the easiest way to train an LLM on LangChain docs? I know how to do this for text and PDF, but is there an easy way to read all the LangChain doc source?
There is actually like a super easy way. So we even have a notebook that shows you how to do it. I'm going to put it in the chat. But you can just like I can't remember what command is, like wget or something, to get all of the HTML documents from the LangChain docs. And then LangChain have I think it's called the read the docs loader. If I'm not mistaken, you can use that to just process all of the LangChain docs, and then you can do what we did here, what Francisco took us through, where you're like putting you're chunking all those docs, putting them into Pinecone, putting a conversational agent over the top of them, and then talking with them.
Right. For embeddings, we seem to be using OpenAI API now. Would it make sense to encode/embed with home build tool from Llama?
I mean, I've never used it, but I mean, 100%. Like it's not just OpenAI for embedding. Not even like OpenAI have very good completion models, but in terms of embedding, they're not as far ahead with that as other embedding providers. Like they're very good and they're incredibly cheap. That is one big pro of OpenAI. But there are a ton of other embedding providers. I don't know about the one that you just mentioned. I haven't used it. But there's a ton of the ones like Cohere. They have a really good multilingual embedding model. I'd definitely look into that if you're doing anything with like multiple languages. And there are tons of other options out there, open source, well, you have Hugging Face. Yeah, there's a ton to look into.
I think if I'm on, the question said something about locally hosting the embedding process. Is that right?
Yeah, to encode embed with home build tool from Llama was the question.
Home build tool.
Would it make sense?
I agree with James. I think there's many good embedding solutions out there, and I would definitely check out also the Sentence Transformers repository for open source models. And I have used Cohere's multilingual embedding model with great success. I think it's really good.
It's a good call out. Of course, we have, I feel like every webinar, we have a chunking related question. So will you discuss the most appropriate use cases of the various chunking methods from LangChain? I would love to hear your thoughts on how to pre-process a large amount of data most efficiently prior to storage.
I think it depends a lot on your use case. Basically, like rule of thumb, and this is just very basic, like introduction to chunking. Like rule of thumb, if the chunk makes sense by itself to you as a person, then it probably has enough meaning in there for you to kind of create a chunk from that. So the first thing you need to do is just look at your data and see roughly how many tokens create those sort of those chunks that are genuinely meaningful. The text splitter we use here was called the recursive character text splitter. That is probably the default text splitter I would go for, because it's super flexible and it's going to give you it's going to give you the it's going to split your text based on an order of preferred characters, right? The double new lines, single new lines, full stop, all that stuff, right? So that's really useful. You also have the number of chunks, the chunk size, which is the number of tokens in there. Generally speaking, what I go for, and it's just from testing, it seems to work quite well. Is anything between 200 to 400, maybe 500, is usually a good range. But again, you need to have a look at your data and see what makes sense to you as a human, and also include your chunk overlap. So you have, let's say you have like 20 or 40 tokens that overlap between chunks. So that means that you're not cutting any like context between your chunks, so that you're like not missing any important information. They're very general guidelines. There's probably a lot more to it. Francisco, if you have anything to add, please do.
No, I think what I would emphasize what you said at the beginning of, with these applications, there's less of a silver bullet than actually thinking about what would you need to be able to answer the question, or how would you ask a question to another colleague. Like with LLMs and with these new solutions, I would encourage you to actually see like what chunking methods gives results that you would be able to answer a question from, and that do not have a lot of extra information, because that adds noise to the embedding. So just definitely try out a few different chunk sizes and see if the results make sense to you.
Great, thanks guys. Let's say I have 3 fine-tuned models. Is it possible to have a chatbot that knows which fine-tuned model to filter its output with, depending on the context of the user's query?
I'm not sure how would you filter content with the fine-tuned models?
Any thoughts there, James? Or
so to filter, I maybe, yeah, I don't think you necessarily mean filter. I mean, maybe it does. It might be something else. But the way that I read this is actually more like, is it possible to have a chatbot that knows which fine-tuned model to use for a particular query, right? So imagine you have like multiple like large language models, and each one of those is good at a particular thing, right? Then you have kind of like another model that decides which one of those to use for your particular query. You 100% can do that sort of thing, and it's actually one of the things that LangChain does pretty well, as far as I know. Don't know. Francisco, maybe you might have some more input on that.
I would just say that sky's the limit on what you can do with tools, as long as you describe with precision when you wanted to use each tool, and you wrap the model in a function which has some kind of natural language input. Anything you want can be done. So you can have, for example, sub-agents that have specific knowledge, and you can tell your agent to use whichever agent needs to be used depending on the query, that maybe are trained on different data or anything that is possible.
great. And on that note, we are at time. Thank you both so much for joining us today. Again, this has been recorded, and we will be sending out the recording shortly. Thank you all for joining us. Had a great time. Round of applause.
Thanks all.
Bye, everybody.
Thank you all. Bye-bye.